Today, we will see what is a periodic function and what are some characteristics of this periodic function. Now, the main idea here is that we're going to see some examples of a periodic function. A periodic function is any kind of function that has a pattern, which is pretty important. It needs to have a pattern, and that pattern needs to be repeating. So if you see a graph that has a pattern and the pattern keeps repeating, then we can label that graph as a periodic function. Now, if you have a graph that follows a pattern, then we can identify the period of the function, which is basically saying how long does it take for that pattern to complete one full cycle. So this is the idea for today. We will see some examples of periodic functions. Some examples are not periodic functions. And if we see that our graph it's a periodic function, then we're going to identify the period of that function. So let's see some examples here. Now, like I said, we want to identify if the following functions are periodic, and if so, we need to find the period of that function. Now, let's look at the first graph here. Let's analyze it. Well, the first thing they want to see is, does it follow a shape? I see that it has this kind of snake shape, and it's always hitting those same spots. It always goes from -5 all the way to 1. I'm sorry, -1, and it goes to -5 to -1, and it always follows that same pattern. Because this graph follows that same pattern, then this is called periodic. Because it always follows that same pattern and it's always hitting the same y values. So now, because this graph is periodic, then we can talk about the period of the function. Now, how long does it take for this graph to complete one full cycle, to complete one full shape? Well, the easiest way to do it is just pick 2 points, low points, and see how long does it take for this graph to hit those 2 points. Okay, so notice that if we keep doing that same shape, we're going to obtain the graph itself. So let's see, if we continue the same graph, we're going to have the same shape. So how long does it take for this graph to complete one of those patterns? And that will be our period. So now here we start from -5 and we go all the way into -1. So here this is 4. And notice that every cycle is going to have the same length. So it takes 4 units to complete each of those cycles. So that says that the period of the function is just 4 units. You only need to identify one cycle. But here I show 3 of them, so you can see that every 4 units, you're going to complete that same shape over and over again. So let's look at the next example here, in example 4. Notice that this is periodic. It's exactly the same shape as the top. It goes from -2 all the way to 0, and it follows always the same shape. So this is periodic, which is excellent. Now, this is periodic, so let's write that down. Because this is periodic, then we can find out what the period is. The easiest way to find it is just locate 2 low points and see how long does it take me to get from that low point to the next low point. So let's estimate here. Let's say that this is close to -2 and this is close to 1. So how long does it take me? It takes us about 3 units for us to complete the full shape. So that says here that the period of the function is 3 units. And notice that if we do another cycle, we're going to have to travel 3 units again to complete that other cycle. Every period, it follows that same shape, and it needs to follow the same period of the function. It always needs to follow those the same shape and the same length for it to complete that same shape. So now let's look at example 3 here. Now, can this be labeled as a periodic function? Well, let's see. It follows that same shape. It's always going to follow that same shape, squiggly line. But notice that, is it always hitting the same y values? No. Even though it still has the same shape, that curve shape, it's getting smaller and smaller. So the shape of the graph keeps changing, even though it follows that same pattern, but the shape of the graph keeps changing. So this is an example of something that is not, this is not, this is not periodic. Because yes, it follows a pattern of an upside down shape, but it's getting smaller and smaller. So let's look at another example. It doesn't always have to be some kind of a curve shape. You can have squares here, but the idea here is it always following that same pattern? Well, to me, it does. It always follows that same pattern. So you go to the right, up, right, down, right, up, right, down, right, up, right, down, and it follows that same pattern. So this is periodic. It doesn't always have to be some kind of a curve shape. So now, what do we need to find out is, what is the period? So to me, I would locate the lower right point of one of those mountains here. So let's see, how long is it going to take me to go from this point to that same point to the right? How long does it take me? Well, here, let's say that this is negative 0.5. And now here, this is 1.5. So how long does it take me to go from negative 0.5 to 1.5? That's 2 units. So this says that the period of the function is 2 units. So now again, we can do the same on the left side here. We have a lower right point of the mountain. So here's another lower right point of the mountain. So now let's see, how long did it take me to go from here to the next lower right point? It's still going to be 2 units. From negative 2.5 to negative 0.5, that's 2 units. And the same goes if we want to go to the other. Here's another lower right point of that graph. It's still going to be the same length that you need to travel in order to reach that point, which is going to be 2 units. Let's look at our final example here. Can this be an example of a periodic function where it goes up, then down, and then to the right up, and then down, to the right up, and then down, to the right up, and then down. So it always follows the same shape. So this is periodic. Okay, let's write that again. So this is periodic. So now, because it's periodic, we need to find out the period. So let's identify 2 low points here. So we have low point and low point. How long does it take me to reach to that point? We start at negative 3 pi's. That's what it says here. And then we end up at negative 1 pi. So that says that you need to travel exactly 2 pi's. From negative 3 pi's, if you add 2 pi's, you're going to end up at negative pi. So here the period of the function is 2 pi. Now that same period needs to follow if we want to keep moving and repeat that same shape. We travel 2 pi's as well. Let's do it one more time. From this point to the next lower right point, you're going to travel 2 pi's as well. So that's it. That same shape, it takes 2 pi's to repeat itself. And that's why the period of the function is 2 pi. Now here's your entrance ticket. Identify the following are periodic, and if so, find the period.